Hello everyone in grade 12. Today we will continue the solution of worksheet 1, which is talking about finding the limit of a function numerically by making table. Before I start the solution of the question of this worksheet, I'd like to remind you what is the meaning of the limit of a function when x approaches to the given value. It means if x approaches to which value of y as x, or when x approaches to a given value of x. This means approximately value of y, it approaches to it when x approaches to a given value of x. What is the meaning of approach? Very close, very near, but it is not actual value or real value, approximately. Okay? When we find the limit of a function when x approaches to a given value, I don't care if this function defined or undefined at this value of x, because I'm talking about when x approaches, but it doesn't mean equal. Understand? Now, I remind you by the steps or the instruction that we have to follow to find this limit. As you see here, by making table, I'll find the limit of the function. How? Look here. Just as you look at this table, is divide the values of x into two sets. The first set of values which are greater than x. These sets of value which is greater than what? X equal 2. It means x approaches to 2, but from right, because the right it means more than, greater than. From right I refer to right by writing plus above it. I help you how to write the sentences which we talk about it. Here, x, all of these value of x less than 2 and very close to it, very near to it. This means x approaches to 2, but since it is less than, from left. We refer to left by writing minus or negative above it. Okay? In this case, we have to plug in by the values of x in the given function using calculator. I need in this lesson the skills of using calculator to evaluate any value. Here, if we replace by 1.9 in this function, it will be, please, you have to use the calculator to make sure from my result. Okay, use your calculator to make sure. 0.25564, that is the first value. Replace by this value in the function, the given function will be 0.250. Okay? It's enough to take 4 or 5 decimal places. Okay, here this one for the last value of x which approaches to 2 from left or less than it, 0.2500. That is the value of x for the values of x which approaches to 2 from left. Some values of x. Okay, here find fx when x approaches to 2 but from right. What is the meaning of right? More than. Okay, I refer to bigger than. It means, as you know, the number bigger than any other number, this means it is at its right. By replacing, it will be 0.2499. 0.2494. The other one, 0.2439. That is the first step. Just replace by the values of x, which in these two sets, okay, of values of x in the function. Here, when x approaches, look here with me, here x approaches to 2 from left, fx approaches, approximately, what is its value? Approximately, it is so clear, 0.25, approximately, okay? If we round here, sometime we can round, sometime it is clear, it is so clear, 0.25. Here, if we round, it will be 0.25, 0.25, 0.24, but it's also close to what? 0.25. Since the function fx goes to the same value as x approaches to 2 from left, okay, approaches to 2 from left, or x approaches to 2 from right. fx must be approaches to the same value. Approaches to the same value as you see. 0.25, 0.25. In this case, the limit exists. This limit, look here, this limit what? Exists. And it will be as the value of fx. Approximately 0.25. That is the limit. Here, to find the limit of the function, numerically by making table. By making what? Table. Then, approximate the value of fx when x approaches 2 from left. Then, approximate the values of fx as x approaches 2 from right. If the two values the same after approximation, approximately the same value, approximately the same value, it's okay here, this one approximate or very close to 0.4, yes, because here approaches, not actual value, but approximately, looks like which value. I think it's so easy how to find the limit numerically by completing table. Here, look, I'm sorry, look here with me. Number 2 and 3, it was, they were homework. But I'll discuss with you them. Then I will give you number 4 and the number 5 at the homework. In this lesson, I need the skills of using calculator. Look here. Number 3, how to read this function or this expression, which, okay, as you see this one. Limit. The rational function, as you know, 1 over x plus 1 minus 1 over 4 over x minus 3, when, look here, when x approaches 3. I have to read I don't say limits. Then the function, okay, then when x approaches to which value, that is my lesson. Okay, plug in by the values of x in the function. But as you see, you have to tell yourself many times, this function, or this table, divide the sets of value into 2 sets. Divide the values of x into 2 sets. Here, x approaches to what? 3, but greater than 3 from right. Less than 3, this means from left. Understand? Here, please focus. X, look, x approaches 3 from left. The value of the function fx must be approached to the same value as x approaches from left or approaches from right. Here I have to replace in this function to find what? The value. Okay? And approach these 3 values to or approximate to which value. Okay? This one, if I replace in this function, okay, it will be negative 0.064. You have to replace and make sure your result as as my result or no. Then here, if we replace by 2.99 in the given function, this is function, Okay, it will be negative 0.0625, sorry, 65. I know sometime you will find the result has infinite number of decimal places. It's enough to write 5 or 4 decimal places. I don't need more. Okay, if we replace in the function by 2.99 or 2 and 999 thousandths in the function, it will be negative 0.06251. Okay, if we that is the value of fx when x approaches to 3 from left. Then find the value of fx when x approaches to what? 3 but from right. Replace in the given function. It will be negative 0.0. I'd like to write in different color to show you what about the approximation of fx when approaches from left or approaches from right. Write in blue. Okay, it will be negative 0. I'm sorry, negative 0.06 0.25. The next value, if we replace by 3.0 in the function, it will be negative 0.0. Make sure from my result by using your calculator. Okay, replace by 3.1 in this function, only in the function, which is 1 over x plus 1 minus 1 over 4, all of them over x minus what? 3. It will be negative 0.0697. Clear or not clear? The third step here, I have to round this one or find the approximation of the first values of fx. It will be approximately all of them nearest to what? Negative 0.06 or 2. I think there is here 2, no 4. All of this one, it is approximately negative 0.06. You can write this one, it's okay. You can write 2. Okay. Here the others one approximately negative 0.0. All of them approximately negative 0.062. So since the function fx approaches to the same value as x approaches to 3 from left or approaches to 3 from right, in this case the limit it will be the same. Since they approach it to the same values, the limit exists, and it will be what? What is the value of the limit? Negative 0.062. Understand or no? I think it's so easy. Just to complete the table, round all of the values or find the approximation, all of them approximately close to each value of y. Both of them, if the function approaches to the same value approximately, this means the limit exists and it will be like them. I hope you understand. Before solve the homework, which is question number 4, number 5, please watch the video many times to understand and remember the meaning of each vocabulary. Okay, what is the meaning of limit? What is the meaning of approaches? How to find the limit numerically, because we have different way to find the limit of the function. But in this lesson, we find the limit numerically by completing table. Thank you for joining this session. Okay, don't forget to do your homework. Thank you. Bye-bye.